Future of climate change. Changes in the climate. We've all heard a lot about it during the past 10 years. Also, most of us haven't given it much conscious consideration in our daily lives. Apart for a few milder winters here and more severe storms there, it hasn't really had much of an impact on our way of life. In truth, this winter, 2014-15, has been far less dismal where I reside in Toronto, Canada. In December, I wore a t-shirt for 2 days straight. But, even as I say that, I am also aware that mild winters like these are not typical. I was covered in snow to my waist as a child. And if the recent trend holds true, there could come a year when I go without any snowfall. To me, that is blatantly un-Canadian, even though it could look normal to a Californian or a Brazilian. But, there is certainly more to it than that. First of all, understanding climate change may be quite difficult, especially for individuals who don't understand the distinction between weather and climate. Weather is a description of what is occurring minute by minute, day by day. It responds to queries like, will it rain tomorrow? How much snow should we anticipate? Is there going to be a heat wave? Weather essentially represents our environment and ranges from real-time to up to 14-day predictions, i.e. short time scales. Climate, on the other hand, refers to what is anticipated to occur over a lengthy period of time. It is the trend line in the long-term climate prediction that spans, at least, 15 to 30 years. But, it is the issue. These days, who the hell truly plans 15 to 30 years out? In reality, for the most of human evolution, we have been trained to prioritize the here and now, to disregard the distant past, and to pay attention to our current environment. It is what has kept us alive for millennia. But that's also why dealing with climate change is so difficult for modern society. Its worst impacts won't be realized for another 2 to 3 decades. If we're lucky, they'll come gradually, and the suffering they'll bring will be felt everywhere. But here's my problem. The reason climate change seems like such a low priority concern is that it would be too expensive for people in positions of power today to solve it in the future. The current crop of elderly politicians won't be around in 2 to 3 decades, so they have little motivation to upset the status quo. My generation will pay a considerably higher price to direct our ship away from the waterfall that the baby boomers are guiding us towards at this point in the game. This implies that compared to earlier generations, my life as a gray-haired senior may cost more, have fewer possibilities, and be less enjoyable. That's awful. In this series of videos, climate change will be explained in terms of current events. Sure, the most recent information describing it will be provided to you, but you will also understand how it will differ in other regions of the world. You'll discover how climate change may affect your daily life, but you'll also discover how, if left unchecked, it may trigger a world war in the future. Finally, you'll discover the significant and insignificant actions you may do to influence change. What is actual climate change? In this video, we'll use the common, Googled, definition of climate change, which reads as follows. Change in global or regional climatic patterns owing to global warming, a steady rise in the Earth's atmosphere's general temperature. The rising quantities of carbon dioxide, methane, chlorofluorocarbons, and other pollutants created by nature and people in particular are often blamed for this as part of the greenhouse effect. Eesh. That was a lot to say. Yet, this won't become a scientific lesson. The crucial fact to remember is that the carbon dioxide, methane, chlorofluorocarbons, and other pollutants that are predicted to ruin our future typically originate from the following sources: the oil, gas, and coal used to power everything in our modern world, released methane resulting from the melting of permafrost in the Arctic and warming oceans, and large volcanic eruptions. Another important fact to be aware of is that our planet will become hotter the more of these toxins there are in our atmosphere. The majority of the international agencies in charge of planning the worldwide effort to combat climate change concurred that 450 parts per million is the maximum greenhouse gas, GHG, concentration we can allow to build up in our atmosphere, ppm. The 2 degrees Celsius limit is also known as the number 450, which roughly equates to a temperature increase of 2 degrees Celsius in our environment. What makes that restriction so crucial? And if we surpass it, our environment's natural feedback loops, which are discussed later, would speed up beyond our control, causing climate change to worsen and accelerate, perhaps resulting in a future where we all live in a Mad Max movie. Salutations from the Thunder Dome. What is the present level of GHGs, especially carbon dioxide? The Carbon Dioxide Information Analysis Center reports that as of February 2014, the content was 395.4 parts per million. Oh, and just for background, the number was 280 ppm before to the Industrial Revolution. Well, so the distance to the limit isn't that great. Shall we run away? That depends on where you reside on Earth. Why is a difference of 2 grades so major? The average body temperature of an adult is around 99 degrees Fahrenheit 37 degrees Celsius, for some plainly non-scientific context. When your body temperature increases to 101 to 103 degrees Fahrenheit, a difference of just 2 to 4 degrees, you are diagnosed with the flu. So why exactly does our temperature rise? To eliminate bacterial or viral illnesses from our bodies. Our planet is the same way. The issue is that we are the illness it is trying to eradicate when it heats up. Let's look more closely at what your politicians fail to inform you. What politicians and environmental groups fail to clarify when they refer to the 2 degrees Celsius limit is that it is an average. It is not 2 degrees hotter everywhere evenly. Ocean temperatures are often colder than those on land, thus 2 degrees there can be closer to 1.3 degrees. But, the temperature increases as you move farther inland and is significantly higher where the poles are located. There, it may be up to 4 or 5 degrees hotter. The worst part about that final statement is that if the Arctic or Antarctic gets hotter, all that ice would melt much more quickly, creating the terrible feedback loops, again, explained later. So what may actually occur if the climate warms up? Water war. First, be aware that the overall quantity of evaporation increases by around 15% for every degree Celsius of climatic warming. Major water events, like hurricanes on the order of Katrina in the summer or massive snowstorms in the dead of winter, are more likely as a result of the more water in the atmosphere. Accelerated melting of the polar glaciers is another effect of increased heat. Because to both the increased amount of ocean water and the fact that water expands in warmer seas, this results in a rise in sea level. This might result in higher and more frequent floods and tsunami occurrences that affect coastal towns all around the world. Low-lying port towns and island nations, however, face the risk of submerging completely. Moreover, freshwater will soon become a reality. In the next 2 decades, expect more media coverage on freshwater, which is the water we use to drink, bathe in, and irrigate our plants. This is especially true as freshwater becomes increasingly scarce. You see, alpine glaciers will gradually regress or vanish as the Earth warms. This is significant because mountain water runoff supplies the majority of the world's rivers, which are our primary supply of fresh water. Yet the majority of the world's farming potential would be lost if the world's rivers shrank or dried up entirely. For the 9 billion people who are expected to exist by 2040, it would be awful news. In addition, starving individuals frequently exhibit extreme desperation and illogical behavior when trying to survive, as you may have seen on CNN, BBC, or Al Jazeera. There will be 9 billion hungry individuals, which is not ideal. In connection with the aforementioned facts, you may conclude that if more water evaporates from the oceans and mountains, more rain won't fall to irrigate our farmland. For certainly, yes. Yet, a warmer climate also implies that our most arable land will experience higher rates of evaporation, meaning that in many parts of the world, the advantages of heavier rainfall will be offset by a quicker rate of soil evaporation. That was water, I see. So, using an unnecessarily dramatic topic subheading, let's talk about food. The food wars. Our media frequently focuses on how food is produced, how much it costs, or how to prepare it before eating it when it comes to the plants and animals that make up our diets. Our media, however, rarely discusses the real availability of food. That's more of a third world issue for the majority of people. The fact is, however, that as the planet warms, our ability to produce food will face grave threats. A 1 or 2 degree increase in temperature won't cause too much harm, we'll just move food production to regions with higher latitudes, like Canada and Russia. Nevertheless, a senior scholar at the Peterson Institute for International Economics named William Klein claims that a temperature increase of 2 to 4 degrees Celsius can result in food crop losses of around 20 to 25% in Africa and South America and 30 or more % in India. Another problem is that, in contrast to earlier farming, industrial farming tends to rely on a relatively small number of plant species. We have tamed crops that can only flourish when the temperature is just right, either via thousands of years of hand breeding or hundreds of years of genetic engineering. For instance, research conducted by the University of Reading on 2 of the most popular rice cultivars, Lowland Indica and Upland Japonica, found that both were extremely sensitive to increased temperatures. More specifically, the plants would become sterile and produce few, if any, grains if temperatures during their blooming periods surpassed 35 degrees. Given that many tropical and Asian nations, where rice is the primary staple food, currently reside on the extreme edge of this Goldilocks temperature range, any more warming might spell disaster. Feedback loops, finally an explanation. Thus all these experts are concerned about concerns like a shortage of fresh water, a lack of food, a rise in environmental disasters, and mass extinctions of plants and animals. But, you assert that the worst of this is still at least 20 years away. Why should I be concerned right now? On the basis of our existing capacity to assess the output patterns of the oil, gas, and coal we burn year after year, scientists suggest 2 to 3 decades. We're tracking that information better now. The warming impacts brought on by natural feedback loops are harder for us to monitor. Every cycle in nature that either positively accelerates or negatively decelerates affects the rate of warming in the atmosphere is referred to as a feedback loop in the context of climate change. When our planet heats, more water vapor enters our atmosphere, increasing the amount of clouds that reflect sunlight and lowering the average temperature of the world. This is an example of a negative feedback loop. Regrettably, there are many more positive than negative feedback loops. The list of the most significant ones is as follows. The ice caps at the North and South poles will start to melt and decrease as the globe warms. The sun's heat will no longer be reflected back into space by as much shining white, icy ice as a result of this loss. Remember that our poles may reflect up to 70% of the heat from the sun back into space. The rate of melting will increase more quickly each year as heat is reflected away from the surface less and less. The permafrost, the soil that has been locked in sub-freezing temperatures or buried beneath glaciers for generations, is melting at the same time as the polar ice caps. Massive volumes of stored carbon dioxide and methane are present in the frigid tundra located in northern Canada and Siberia, and once warmed, they will be released back into the atmosphere. More harmful to the environment than carbon dioxide, methane cannot be readily absorbed back into the soil after it has been released. Lastly, our seas are the largest carbon sinks on Earth, like global vacuum cleaners that suck carbon dioxide from the atmosphere. Our ocean's capacity to store carbon dioxide declines as the planet heats year after year, which means that they will absorb less carbon dioxide from the atmosphere. The same is true of our other major carbon sinks, our forests and soils. As our atmosphere gets more contaminated with warming agents, its capacity to absorb carbon from the atmosphere decreases. Geopolitics and the possibility of a world war caused by climate change. You should now have a better understanding of the problems we're experiencing on a scientific level after reading this condensed summary of the situation of our climate today. The problem is that understanding the science behind a problem better doesn't necessarily make the point more emotionally compelling. In order for the general population to comprehend the effects of climate change, they must be made aware of the very real effects it will have on their own lives, the lives of their families, and even the lives of their nation. Because of this, the remaining parts of this video series will examine how climate change will alter the politics, economy, and standard of life of people and nations all over the world, assuming that just lip service will be paid to the problem. Climate wars, because, in a very real sense, countries all over the world will be engaged in a struggle to preserve their way of life.